Go, number 12. A meteor whose mass is about this struck the Earth. I think of a song. Oh, one of the Newsmas girls. Comet struck the Earth.
Daddy, is your dad gonna come sing those again?
I don't know if you got it.
He tried to get us to go sing and we were like, no.
All my classes went.
Of course, we got like a 0. We actually had to do it. We didn't try, like, put one off.
He did like the 12th with baby.
Alright.
Like number like 3.
What was the Earth's recoil speed? Alright, so we're looking at some conservation momentum here, right, folks? Okay. And then what fraction of the meteor's kinetic energy was transferred to the kinetic energy of the Earth? And how much did the Earth's kinetic energy change as a result of this collision? So, let's see, number 12. How much momentum is the Earth going to have before the collision?
0.
Why am I doing capitals? Meteorite. Right, and they're going to join into one body afterwards, yes? Yeah. Inertia of the meteor, velocity. You don't, what did you just turn off? All right. So let's see. We have the mass of the meteor and its speed, velocity ahead of time, right? 10 to the 8 kilograms. And it gives us the mass of the Earth. 13 kilograms second. Now notice, what do they want the recoil speed in? Meters per second.
Not meteors.
Meters. So basically you have everything, except I would change that 13 kilometers a second to 13,000 meters per second. So let's see. So we've got 1 times 10 to the 8th. Yep. 8 kilograms times 13,000. I mean, we're being very cautious here. In the second part here, how much is 1 times 10 to the 8th going to change 6 times 10 to the 24th? None, really. So, I mean, you could have just said, well, the meteor is, well, no. It's not going to be 0, but what I'm saying is if you had forgotten that one mass, you would have still gotten to the ballpark. Let's double check. I get 2.17 times 10 to the negative 13. And then what fraction of the mirror's kinetic energy is transferred to kinetic energy of the Earth? I would do C first. By how much did the Earth's kinetic energy change as a result of the collision? So I'm gonna, this was A. And then I was gonna do C next, since the change in kinetic energy is KE final minus KE initial, and KE initial was 0. Actually, yeah, you can do it either way. You know what? Well, what did this be? What fraction? Oh, that's no. So 1/2 inertia of the Earth, velocity of the Earth squared, right? Yes, and you could solve that. Then for part B, you're going to put your delta KE over KE of the meteorite initially. Actually wants to know what fraction of the meteorite's kinetic energy. They actually want to know the percentage was transferred to kinetic energy of the Earth. And then multiply that by 100%. Give those a try. Tell me if they don't come out. I'll give them a try. I'll tell you if they don't come out. And we'll all be happy. Theoretically. Or momentarily. Folks, I thought I'd go on to number 6 here. The tennis ball hitting the other one. And I think I will capture this one and transfer it to my other one. Did you make sure you wrote it as a percentage? In other words, did you get your answer and then multiply it by 100%? No, you did your math backwards. That should have been a really small answer. All right. Now we're back from the crash of smart, so try it again. So folks, key in number 6 here is that it's an elastic collision. So we've got our tennis ball and our larger ball. This one is moving at, this is 0.06. This is 0.08. This one's moving at 7.3. This one's moving at 3.2. Since it's a lighter ball hitting, guys, remember, if you're working on the side, that's fine, but just keep down a little bit. If a lighter ball is hitting a larger ball, my prediction is that the lighter ball is going to end up moving negatively. And the bigger ball is going to end up moving positively. They would only stop if they had the exact same mass. And although the 0.6 may continue on, we'll have to see. I'm thinking it may continue on now because, so we need that our mass is our inertia and our momentum. So our momentum beforehand has to equal our momentum afterwards, and our kinetic energy, our total kinetic energy before, has to equal our total kinetic energy afterwards. Those are our two conditions here. And so we kind of need to work those simultaneously I know you guys like the simultaneous equations. So here we've got, we'll call this ball 1 and this will be ball 2. Inertia of 1, velocity of 1 before, plus the inertia of 2, velocity of 2 before. That has to equal, those are velocities, so we need directionality, just like we need there. The inertia of 1, the velocity of 1 afterwards, plus the inertia of 2, velocity of 2 afterwards. Then here on our other side, we have 1/2 m1 v1 squared plus 1/2 m2 v2 squared equals 1/2 m1 v1 prime squared plus 1/2 m2 v2 prime squared. We know m1, we know m2, we know v1, we know v2. We don't know either the primes, so we have 2 equations with only 2 unknowns, same 2 unknowns, solvable. Right? But so some things that could help me, just reducing things. What I would do probably is solve my green equation and put it into my blue, or use my calculator to maybe even graph the 2 and look for the intercept. If I was doing it at home, I'd probably throw both of them into Wolfram and let it plug and chug on it. If I'm doing it with my calculator, I'm definitely going to substitute one in for the other. So let's assume that I'm doing it with my calculator, since that's what I have on the test, right? So I'm going to rearrange this green one for v1 prime. So I'm going to have m1 v1 plus m2 v2. That's all known, so that's just all one happy number. Minus m2 v2 prime. All that over m1 is going to give me v1 prime. And then that's what I'm going to substitute into my blue equation here. Maybe not even reduce it much. Remember, this whole side of my blue here is a number. Just like this whole part here is just a number. So I can solve for those values and not make this look scary. All right? So that's basically to do that algebra. And you're good. And if you need help with keeping track of the algebra, I will come over and help you.